Hi, my name's Dave Doucette. I'm the Hardware Systems Development Director here for 6500. I'm in the Ottawa labs at Ciena. I'm going to talk to you about the future of 400 gig E and show you a live, first world ever demo of 400 gig E interop between a test set and our equipment. We at Ciena decided to work with a test set vendor and partner to come up with a demonstration of our ability to support a 400 gig E service using our Flex 3 technology. We built a 400 gig E prototype card which would interface with an Ixia test set. That interface uses a definition of 16 PCS lanes of 25 gigs each. These 25 gig lanes are each carried over a LAN WDM grid using 25 gigs per channel. This over here is a 400 gig E test set, a prototype test set that was developed by Ixia, and we're demonstrating interop with that test set right now. Ixia's approach to delivering 16 lanes of 25 gig was to use CFP2 LR4 optics, each of which carries 4 logical lanes of 25 gig. The 400 gigs of traffic is spread across all 16 lanes and comes out the 4 sets of fibers. These 4 sets of fibers travel over to our 400 gig prototype, which is right here. That 400 gig prototype takes those 4 fibers, come into our client card, are fed to 4 LR4 modules. Each of these is carrying 4 lanes of 25 gigs for a total of 16 feeding an FPGA. This FPGA is monitoring the PCS layer and converting the signal or mapping the signal into 4 OTU4s that will be carried to our 2 16 QAM cards, one on each side. These are production grade WaveLogic 3 Flex 3 circuit packs, and you can see them right here. Okay. Those wavelengths are being carried, these 2 16 QAM wavelengths are being carried over a line system. So behind me is a bunch of equipment, and this pictorial shows you what is in that setup. So going through the pictures, we had the 400 gig E test set that we talked about previously. That's feeding our 400 gig E prototype card. That's feeding 2 16 QAM Flex 3 OCLDs, which is generating 2 wavelengths as shown here. And all of that is feeding into this photonic line system. So the photonic line system itself is a 10-span system. We are launching across 10 spans and optically looping back at the far end to come back for another 10 spans for a total of 20 spans. The total reach of that system is 1,550 kilometers. So we're running 2 16 QAM waves carrying a 400 gig E service over 1,550 kilometers. I'm also applying impairments in this system. And what I've included here to do our PMD demo is a set of 4 PMD emulators. PMD emulators were designed to generate up to about 200 picoseconds of DGD each. For our demonstration, I need 4 of these to show our PMD tolerance. In between each of these PMD emulators, I'm putting a polarization rotator. There are 2 ways I could show you the worst case PMD. One would be to attempt to align all 4 of these PMD emulators to the same orientation. Another one is to put rotators in. Rotators is much more straightforward to do in a test environment. It does mean, however, that what I will be showing you is going to be a statistical representation of the PMD. So the rotators are right here, and here are 2 of the PMD emulators. And there are 2 more rotators here, and 2 more PMD emulators here. This fast polarization rotator is running at about 1K rads per second. This is equivalent of the worst case one would expect to see in an aerial fiber plant. So not only am I going to be applying large amounts of PMD, but I will be applying it in a method that shows PMD transients at the rate that you would see in a worst case aerial fiber plant. This screen here shows how much PMD is being experienced And since the measurements are being made on a short-term basis, they're really DGD measurements, or differential group delay measurements, effectively. I'm starting by applying 150 picoseconds of DGD, and we're going to increase from there. I'm going to now increase the value. We'll increase it by 200 picoseconds of DGD. This number is showing how much I've requested from the test setup. This next number is showing how much is actually being applied by the equipment. And the next number that says overall max is showing how much is the worst case that each of the OCLDs have shown as their samples in this screen. So in between those samples, the OCLDs are seeing more than what you're just seeing on this sample screen. We are seeing a purely statistical view of what's going on in this system. As you can see on my test sets over here, everything is running clean. That's with 350 picoseconds of DGD applied. I'm now going to increase it again. So we're now at 550 picoseconds of DGD. And again, my test sets are running clean. I've got one more step now I can apply. So now we're at 750 picoseconds of DGD applied. Again, all my test sets are running clean. So we have 750 picoseconds of DGD applied. That's the equivalent of roughly 250 picoseconds of mean PMD. We're running over 1,550 kilometers of NDSF fiber using just EDFAs, no Raman. The PMD is being applied with an aerial rotation rate, and we're carrying a 400 gig E service over that. Thank you for watching this demo today. We appreciate your time.